Okay, so here we're factoring this polynomial, and when you have a polynomial of this form, where it's x to the third power, then you have x to the second power, and then just x, or something similar, it's probably best to factor by grouping. That's, I think, probably the most efficient way to deal with this. And it's not so hard to do. To factor by grouping, the first step is to group the higher powers together. So I would group x to the third minus 2x squared, and then I'm going to group the lower powers, so 4x, right, and then 8, so positive 8. And here, if you want to, right, you get the subtraction sign to connect these two, we want to think about that. So in fact, we're subtracting 4x and subtracting 8, so really we want to write that as negative 8, right, to preserve the original positive. And all I mean there is, if you think about how the subtraction is being distributed, we're subtracting 4x, that would give us the negative 4x that we need, and we're subtracting a negative 8, which would give us a positive 8, because subtracting a negative is the same as adding. So now, the next step is to factor out anything we can. So here, these two terms have x squared in common. If I factor that out, we have x squared times x, right, minus 2. Just kind of pulled the x squared out. And here, what do we have in common between both of these? We have a 4 in common, so we pull the 4 out, then we get x minus 2. So now we're essentially done. So now just bear with me on this next step. I'm going to explain it, but essentially what happens now is that in both terms the common factor is x minus 2. So we can rewrite this as x minus 2, x squared, x minus 2 times x squared minus 4, right? Now, that might be hard to see about why that's true, but let's just take a sidetrack for a moment over here. Let's pretend that you have, I don't know, 2 times 3 minus 4 times 3. Well, here, notice 3 is the common factor. So couldn't we just say this equals 2 minus 4 times 3? Right? Because if we distributed that 3, it would be 3 times 4 and 3 times 2, or 3 times negative 4 and 3 times 2, and we would get back to our original term up here. If you're having a hard time seeing that, you can kind of reverse the order of these two. So it says, instead of 2 times 3, 3 times 2 minus 3 times 4. Then again, the common factor is 3, so we can think of it as 3 times 2 minus 4. Right? Same idea. That's what's happening here, really, though it's just much harder to see because we don't have simple numbers but entire terms. This number is a common factor in both, right? And then it's being multiplied by these two terms, x squared and minus 4. If it helps us, we can rewrite it as this, x minus 2 times x squared, just reverse the order, minus x minus 2, right, times 4. And then you might be able to see that, oh, the common factor is x minus 2, so we pull that out. And now we're basically done, except here we have the difference of two squares. It's x minus 2 times x plus 2, and you can test that, it should work out, times x minus 2. Right? And here, now, notice that we basically have two factors. This has to equal 0, as it says originally up here. So one of these, or more of these, could equal 0, but two of them are the same, x minus 2. So that'll be a repeat, right? We have x minus 2 equals 0. Add 2 to both sides, and x equals 2. Here, x plus 2 equals 0, right? There, if we subtract 2, we have x equals negative 2. So x could equal positive or negative 2 in this polynomial, and that will be equal to 0. And you could plug it in really quick. We'll try one of them. 2 to the third is 8, minus 2 squared times 2, which is 8. That's 0 right away. Minus 8, right, 4 times 2 is 8, plus 8, and that is 0. And the same thing happens for negative 2. So this does work. Alright, hope this helped.